Hello guys, in today's video we are going to see how to call the tool with the help of LangGraph. So today we will have one node that will be an LLM node. So with this node we are going to attach just one tool. Its name will be add tool. So basically this add tool will add two integers or two numbers and return the result. So basically what are the tools? We attach tools with the LLMs so that our LLMs have more capability. So maybe in future video we will attach Google search tool. Our LLMs do the Google search and return the recent result. LLMs don't have the recent data. Another example, maybe we have the LLMs and with this LLM we attach maybe or add another tool in future that will fetch the data from SQL database. So this LLM write the SQL query and call that tool. That tool fetch the data and give the result or response back to LLMs. So on the basis of that result, LLM generate the response. So in today's video, let's add this add tool that will add two numbers. Here I import annotated sequence type dictionary system message. In previous video we already see what is annotated sequence. So let me just revise you. Here we are saying marks is annotated of integer and between 0 to 100. So annotated is basically used to add extra metadata. So here we took the example. We are saying marks will be an integer type. But what if we want extra detail like marks will be between 0 to 100? So we use annotated. So here there is clear marks will be integer type and it will be between 0 to 100. If we want to print metadata, we print this way, marks dot metadata. It print between 0 to 100. And similarly we have different kinds of sequence like list, tuples, range, string. So one way is to define, we are saying X will be list, tuple or range or string. Or another way or another best method is we are saying X will be just sequence, mean any sequence. It may be list, tuple, range or string. So by using this annotated sequence, let's define our agent state. I am saying class agent state. It will be inherited from type dictionary. And we have messages. Messages will be annotated. It will be a sequence of base message. We define the base message here. We import the base message here. Base message is basically base class of all these messages type. So here there is a clear message will be a sequence of base message. Mean it will be any sequence. It will be list, tuples or anything. Then we saw that add messages reducer function. So what add message reducer function do, basically it automatically update the state. So previously we have messages. In messages there is hello and then we add how are you, this message. And without reducer function our final state messages will be how are you, means this updated message. Our previous message was gone. So with the reducer function we have this message, there was another message, second message, we update the state. Our final state will be hello, how are you, mean previous message and new message as well. It is the benefit of add messages. So simply we will say add messages. Now we don't need to append the messages in state. Our this function add messages automatically add the messages in state and it will not remove the previous messages. So it is basically an annotated. Similarly similar to what we saw, that annotated of integer between 0 to 100. So just consider this integer is this type sequence of base message and this between 0 to 100 is this one add messages. Okay, perfect. You can understand the add messages role in a while. Let me just run it. Now we need to define the tool. I will call the decorator this one. Here from langchain.core tools I import the tool, and let's define our tool. I will say add, its name will be add, and it will add two numbers. Its type will be integer, number 1 and number 2. And most important part, here we must add the doc string. So doc string basically tells to the LLM what our tools will do, or what this function will do. I am saying this function add two numbers together. Sum is equal to num1 plus num2, and we will return the sum. So you define the tool this way. You must add the doc string. In doc string you explain what your tool will do. Let me just run it, and here I will say tools is equal to, we have just one tool, that is add tool. In future we maybe have addition tool, multiplication tool. So by defining that tool I will add this way, multiply. And we maybe have Google search tool, I will add this way, Google search. So this list may be increase on and on, but for now I just only have one tool, that is add. So I store it in tools, this variable. Let me just run it. Now we need to initialize our LLM. I am saying LLM is equal to chat olama, and our model will be Qwen 2.5. It is most important part. So before calling the tools with LLM, you must check either your LLM have the capability to call the tool or not. Qwen 2.5 is open source and it is free, and it is pretty good in calling the tool, basic tools. But when we have to call complex tools, we mostly use OpenAI's LLMs. OpenAI's LLMs are beast. They are very good in calling the tools. So to bind the tool with chatolama, I will simply call .bind tools, and here I will pass the tools, this thing. Let me just run it. Now we successfully bind the tools with this model Qwen 2.5. Now we have to define our LLM node, tool node, and we need to build our graph as usual as we do. I will say define LLM node, will pass the state, that will be an agent state. It will return agent state. It will be agent state. For debugging purpose, I will simply print state. Here will be double new lines. Now to instruct the LLMs, I will say system message. It will be like you are helpful assistant that answers the user's question accurately. It will be system message. You can change this if you want. I will store this in variable like system prompt, this way. And now we have to call our LLMs. So I'm saying LLM.invoke. I will pass the system message, system prompt, sorry, plus state messages. In state messages, there will be human message, actual message, what we will pass later on. And you may be remembered previously we need to update our state like state messages dot append. Here we append the response of LLMs and whatever response, this way. and also I need to store this in response. But you may remember we add this add messages, this reducer function, so we don't need to append the messages. This add messages will automatically append the new message in state messages. So instead of doing this way, I will simply say return messages just response. It will automatically append the new message in previous message. It will not replace the new message with previous message because we add this add messages. We successfully create this node. Now we have to create this edge or this function that will decide either we have to end the graph or we have to go to ToolNode. Here I will say define should continue. Here we will pass the state, that will be an agent state, and it will return a string. Here I will access the last message from the state messages -1. It will extract the last message and store it in this variable last message. And here I will check if last message actually I will check if not last message dot tool calls. You have to return and, means if it is not the tool call then just return this string and, else just return tool call. You may be confused like we have not imported the dot tool calls or from where it comes from. So let me just explain. You may be remembered in Python we access the attribute using this way, like user dot name is equal to Ali maybe. So last message is basically instance and tool call is the attribute, and we are just accessing from last message. If there is tool call attribute, if tool call is present, like we are accessing user dot name this way. So don't worry about that. We actually see in state messages like what's going on, then you will understand it better. Okay, perfect. We perfectly define our this node and this edge. Now let's build our graph and add this node. So to build the graph, I will say graph is equal to state graph. I will pass the agent state and I will add the node. I have LLM node. You can change this name. Its name is LLM, and this can call this LLM node. This we add this node, but we have not add this tools node. So to add this tool node, you may be remembered we import from LangGraph.prebuild import tool node. So we'll use this tool node. So here I will simply say tool node, and here tools are is equal to tools. I will pass all the tools. It will be a list. For now in the list we have only one tool. Let's store it in a variable like tool node is equal to. Just consider this tool node as this LLM node. Now we need to add this tool node like we add this LLM node. So to add this I will simply say graph.add node tool node, or maybe tools, whatever you want. It will call this tool node, this thing. Now I will say graph dot set entry point. Our entry point is our LLM node. We have perfectly defined this node, and this first edge. Now we have to add this conditional edge. I will simply say graph dot add conditional edges and from here LLM node will call should continue function, this function. So this function basically return string. It will return this string and or tool call. I am saying if it return tool call, you have to go to ToolNode, so its name is tools, and if it return end, you have to end the graph. We import the end from LangGraph.graph, import state graph and end. We successfully add this edge and these two conditional edges. Now we need to add this edge from tool node to LLM node. So after fetching the data from tools, it returns the data to the LLMs. So on the basis of that data, LLMs generate the response. I will simply say graph.add edge from tools to LLM node, and we need to compile our graph. I am saying agent is equal to graph.compile. Let's run it. To visualize the graph, I will paste the code, and let's visualize the graph. We have LLM node, and if there will be a tool call, it will go to tools node and come back to the LLMs, and if there is end, it will end the graph. Now let's invoke our agent. I'm saying agent.invoke in messages. I will pass some message like add 2 plus 3 maybe, and let's store the result in final state, this variable. It successfully print the response, but for you, let me just print the clean response. So here I will say for message in final state messages, I will access the messages from final state, and here I will check if is instance message AI message, then just print message.content. It will print the clean response or final response. It is saying the result of adding 2 and 3 together is 5. Okay, let me explain you like what's going on step by step. So here we are saying add 2 plus 3. It is basically a human message. From this line, it will come to this LLM node. Here we print our state. In state, there is only human message. Here we are saying add 2 plus 3, and we are printing the state here. It is the state basically. After that, we are invoking our LLM with system prompt and state messages. System prompt is basically this prompt: you are helpful assistant that answers the user question accurately. And in state messages, there is only one message, that is add 2 plus 3. On the basis of system prompt and state messages, it will generate the response, and we are storing the response in state messages. So add messages basically automatically handle it. It automatically append the response in messages. And from LLM node, we come to this should continue function, and we extract the last message. And here we are saying if not last message dot tool calls, mean if there is no tool call, just return end this string, else return tool call. So there was tool call. I will show you in a bit. There was tool call. So from this should continue function, it will come to this add tool, and in number 1 there is 2, in number 2 there is 3. It will add 2 plus 3 and return the result. So after tool call, after calling the tool, it will come to this LLMs, and again it print the state. So here basically we are printing the state, this one. The human message was 2 plus 3. After that, it generate AI message. You maybe see in content there is nothing, it is empty, but there was tool call. Here it is clear that The name of tool is add, and argument was in number 1 there was 2 and in number 2 there was 3. This was the tool call basically. So from LLM it goes to should continue, and in should continue there was a condition: if there is a tool call you have to go to ToolNode. So after calling the tool, this add tool, in number 1 it passed 2, in number 2 it passed 3. And you may be notice there is tool message. It is the message that we get from calling the tool or after calling the tool. It is saying content is 5, mean it successfully execute the tool and return the result. So with this updated state we again invoke the LLMs. So on the basis of tool messages it generates the response that we are seeing here clearly. The result of adding 2 and 3 together is 5. This final response is basically stored in this final state. Let me just print the final state. There was human message add 2 plus 3, and after that there was AI message and content was nothing, but there was tool call. Tool name was add, argument was number 1 and number 2, and it goes to call the tool, and the response we get from the tool, that is tool message, content is 5, this one, and we pass this thing in LLMs and LLM generated the response on the basis of that. That was the result of adding 2 and 3 together is 5, this one. Now I believe that you know how tool calls work in the LangGraph or how to call the different tools. In next video we'll explore this topic in more depth. We add further tools, maybe addition tools, Google search tool, and different tools. So if you are still confused, then don't worry, we'll cover these things in next video. Have a great day guys, take care.